Cool. This is Demystifying APIs. This is basically my journey to learn what an API is. Not a developer by trade. I write a lot of PowerShell over the years. And then I spent a bunch of time working with our PowerShell SDK at Pure on how to efficiently get information out of our devices. And we'll get into all that fun stuff. A bunch of sponsors. I've seen many of you all out at the event, so I appreciate your support there. Let's get into the fun stuff. I'm Anthony Nocentino. I'm a principal field solution architect at Pure. I specialize in system architecture and performance. My job is to make computers fast, and I really love to do it. I specialize specifically in relational databases, which also need to be fast, right? Because that's generally how most businesses function. A bunch of links there. I'll have the content on my GitHub repo. I've blogged about this a bunch last year, and I'll have the links to that. And I'll put it with the conference GitHub repo later today. So we're going to do a couple of things. One, I'm going to define what a REST API is, because I really didn't know what that was until a couple of years ago. And I mostly use that actually in the Kubernetes space and then translate it over into the FlashArray space. So if you're like an API pro, probably not the session for you, okay? But it's about bridging the gap for the operations people that are starting to get to the point where they're consuming these things across multiple domains. Kubernetes, REST API, Azure, REST API, PowerShell in our world is getting consumed by REST APIs. And so we'll get into what that really means. And we'll learn like what it means to interact with an API, to do the things that we want to do inside of a platform. And I promise you there's only 7 slides because it's all demos. Hopefully I'll get through all of those demos today too. This isn't a vendor session, but I had put in the abstract that we're going to use Pure Technologies just to show you how this stuff really works in how a company like ours does these things to manage platforms and information. And so a REST API is, ironically, an acronym, go figure. Although it's kind of like an acronym in a Portman too, it's all mixed together, who knows. But representational state transfer is REST API, right? It sounds super nerdy to be able to change state with a system asynchronously. It's kind of a fancy way to say that. The cool thing about REST is it's based over HTTP, which means we can do it over the internet. We can do it over VPNs. We can manage systems over networks that we already have today. So there's no special protocol that you need to use to interact with this thing. And we probably have all seen this thing on the right, a URI, a Uniform Resource Identifier. It's how to address a discrete thing or object in a resource or in an API. How many of folks have ever hit that dash like subscription ID thing in Azure and wondered what that big long string is? That's a URI, right? Points you to a specific resource in Azure that lives and breathes already so you can interact with it, right? There's a client-server architecture. I'm going to run stuff from a client today, my laptop against the server, which is going to be our compute devices in a lab. Hopefully the VPN works. I have videos as backup, don't worry. But we do this every day over the internet when we're interacting with things like Azure or Kubernetes or whatever it is that we're consuming in a REST API over that client-server model. It allows us to do things like perform operations against those objects, instantiate them, interrogate them, ask for information. And any database developers in the house, anyone ever written, right? So a CRUD operation is kind of the core foundation of this as well. Being able to create, being able to read, being able to update and delete, right? Do stuff with things is really what we're coming down to here. And it really translates back into the HTTP or the kind of the web context of get and post and put and patch. So you'll start seeing these verbs pop up in the operations that you're going to perform, right? We're going to do a bunch of gets today. We'll probably do a little bit of deletes, although I leave those commented out so you don't do anything real bad in an environment. And an API has versions. This is super important from a code stability standpoint. So an API version is kind of a contract between the API producer, like somebody like us or Azure, and the consumer, someone like you, that's writing tooling. It basically says that we're going to produce an API at this version and respect that version over time. When we want to make a new thing, right, a new feature, a new resource in Azure, or a new maybe functionality inside of a FlashArray, we'll move forward in time. We'll make a new version of the API, 1.1, 1.2, whatever that is. But your stuff that you wrote on the 1.1 API will still work, right? Because we don't want to break your code. But over time, we'll deprecate APIs based on the strategy of an organization. What's our API deprecation strategy, Q?
We are going on 2.x, which is a bunch of changes, and we're like down to 2.3.
Yeah, well, over years, how long does it take before we actually deprecate an API inside of Pure? Right, so that's the life cycle of an API is a very long time because it's contract, right, between us and you when you write code. We don't want to break your code is what it comes down to. And so when you're looking at the functionality that's enabled by APIs, I spend so much time in the middle one, actually at the top monitoring. I love performance. I want to get data and do things. And that's where I spend most of my time. But most of the folks here are probably interested in the one in the top left or top right, depending on your perspective, about building automations to do tasks. And so that's really the core that we're seeing in the industry is people shifting away from GUIs and starting to write code to do things. And I'm saying this at PowerShell Summit, go figure. But when I started working at Pure, right, I wrote all of my demos in PowerShell day one. About 6 months into my job, a customer was like, hey, can you show me how to do this in a GUI? And I'm like, actually, I can't, because I'd never done it before in the GUI because I wrote the code first, right? Because that's where we're seeing the industry go. And that took 6 months before a customer pushed back and said, hey, I want to see how to do this in a GUI. And so that's what we're seeing in the industry as well. The other thing that we're seeing is building consistent APIs across different devices, right? Being able to, so that you know you're going to interact with the system in a homogeneous way, right? Not having to learn new tools or new techniques based off of a platform. And so when you start seeing the foundations of a REST API, it'll start clicking across multiple things, right? I can translate what I learned in Kubernetes to what I need to do in Azure from an API standpoint because that contract looks similar, right? The inputs and outputs will be different, but it's all going to be REST. It's all going to have those the CRUD operations that we described, and you'll start to see that pattern over time when you want to build integrations on systems. And so as advertised, we're going to focus on our PowerShell SDK 2, which iterated, I think it was like fall of last year, which iterated on our newest API that came out. So we came out with the new API version, big release, went from 1 dot to 2 dot, changed a bunch of stuff, brought a bunch of new tooling to market, and we want to be able to show that our new platforms are able to consume the API on the V2, and that's where the SDK2 came from. As we kind of highlighted a second ago, our release model for the PowerShell SDK aligns with our API governance strategy, which is a fancy way of saying as the API moves forward, the PowerShell module will move forward too, right? So that we're going to make sure that the functionality that you expect is going to be there. Our internal developers code against, guess what? The same REST API. And so that's kind of another part of how we build things internally is that we're eating our own dog food in the sense that we're just writing the same similar code against the same APIs that we want our customers to do. So there's no special backdoor things that we do. So when you go into the GUIs, you can actually see the same URIs that you'd expect if you're writing code against this at the command line. Specifically about our PowerShell SDK, it's the most consumed integration. I was looking at some stats this morning when Michael Green had his stats on the screen. His were in billions, ours weren't. That's cool, I get it, right? But this is where we're seeing our customers land to in the Microsoft space. So they're doing a bunch of automation in this world. We also have some analogs in the Python world as well. So you can do all the things that we're talking about today in the Python module because it's all backed by the same REST API that the tooling interacts with, right? And that's really the core of our strategy as a company. So, all right, any questions or comments? Because now it's going to get nerdy, right? So guess what I did about 3 hours ago? I had to update VS Code. Guess who's been on conference calls for the last 3 hours? And guess who hasn't tested his demos? So let's see. How high can Anthony's heart rate get during a presentation? Just kidding. I do have videos as a backup, so if it doesn't go off the rails, we're good. Don't worry, team. So that's our PowerShell SDK, SDK2. It's in the PowerShell gallery. So again, kind of fall into that same ecosphere. We have to be able to authenticate to a flash array. And so I'm not going to focus so much on the commandlets that I'm using, but the process of what's going on behind the scenes. And so when we connect to our REST API from the command line, what you can see happen, I have the verbose mode turned on intentionally, is the commandlet interrogated the platform and says, what's the highest version of the API that I can interact with, right? I can specify a specific API version to pin it if I want to, but if we have hundreds of devices, there may or may not be on the same version of software in our system. And so we're gonna go and we're gonna figure out, you know what? We can go all the way up to 2.3, which is the latest version of the REST API on that system. 2.3.1 just came out a couple days ago. And so the idea there is, when you're writing tooling for this type of integration, you might have to build an automation that says, you know what, what's the highest level of API I have access to, and use that, or let someone that has some more intelligence about the integration build that or specify that specifically in their code. So what I'm going to do now is I'm going to connect to a flash array, and I'm going to store that in a variable so I can reuse that object over and over again. So I've authenticated to the flash array, and now I can pass it in as a parameter without having to authenticate again and again. We publish a commandlet, and most PowerShell modules that have this type of architecture publish a commandlet that'll allow you to interact with the API, I don't want to say unrestrictedly, but in a little bit more of a raw way, right? I'm going to communicate directly with the URI and pass in a verb, which doesn't get real sexy over time. That gets actually really annoying because we're going to roll that functionality up into more sophisticated commandlets to expose more advanced functionality. But looking at this here, so invoke PFA2 REST command, authenticated array, get method, right, is the method that want to pass in of all those different ones that we talked about a second ago. And I'm going to go after a particular API endpoint. And so we saw this a second ago when I made the connection. We iterated through all the versions of the API that were available on this particular system that I just communicated with. I'm like, hey, which API versions do you support? Let me know, right? Similarly, I can go after other objects, so volumes, configuration data, performance data, and just say, you know what, give me all of those things. But what I don't get is that back in a very nice output. I just get a big giant JSON blob printed to the screen. I think Joe Hughes just cringed a little bit when he saw that on the screen. That's my buddy right there on my team. So that's where folks will come in, will do the actual parsing and break that data up. That's our job as developers. We want to consume those things. So jumping down a little bit, we can go after that code and run this here. Let's see this one, same one, going after snapshots this time, which is not because it's snapshot. It's be one of those times where I'm going to regret changing my code earlier. So we'll ignore that one. But what I'm going to show you here is that same code when I'm interacting with the REST API, where on get PFA2 volume, I'm going to ask the API for a discrete volume name, which I specified there. And it's on us as developers to make that data accessible to you in a more human readable object format, right? What you'd expect in the PowerShell universe. But I added the verbose parameter up here so you can see the same output that I just got when I interacted with the API directly is actually what's getting transacted between the client and the server. It's just the client's responsibility to make it look nice and pretty so that we can consume it in the object format that we'd expect. And if I go up a little bit further, we can actually see the call here. So we see a get against a specific URL and then URI associated with that. And then all that JSON data is printed to console. So that's kind of the core way that you're going to interact with a REST API at a more polished level, right? Where someone, a PowerShell module like us, is going to make sure that that information is available to you in a way that you expect, not in a giant JSON blob, okay? Because who loves JSON? Oh, really? Okay. Developers, all right? Ops people, look at them funny. So we have tons of commandlets in this PowerShell module. I mean, tons. I think it's somewhere north of 200 commandlets. And navigating that can be a little bit challenging, but as PowerShell pros, we got that under control. And so we're going to look across a couple of different dimensions here today. We're going to look at volumes, we're going to look at the array itself, and we're also going to look at a lot of performance data, because I love performance data. But when I look at the number of volumes that are in this particular flash array that I'm going to work with, I have hundreds, right? A bunch of stuff just flew by. How much stuff flew by? About 900 things, right? So if I go and I interact with this REST API and I ask it for 900 things every time I want to do one thing, does that sound efficient? Right. But as PowerShell pros over the years, we've gotten into this business where we go and we say, you know what, give me all of the volumes. And let's say I want to just find the top 10 volumes in terms of capacity, right? So I'm going to expand a property. I'm going to sort it. I'm going to get the first 10. I'm going to make it look pretty, right? So that's going to go. It's going to get all 900 volumes. It's going to do all that science and math on my laptop here and then print that out the console. Well, there's a better way, right? And that's where the API architecture that we're using and that we see as a design pattern in the industry is this, where you push some of that functionality back into the array or into the REST API so it does that math for you, okay? So same exact output. So I'm going to ask get PFA2 volumes, so get all the volumes on the flash array, but before you give me that back, sort it descending, that's what that little minus sign at the end there is, by total physical space, and then just give me the top 10. And this is all going to happen on the array side. And I'm going to run that, and it's going to print the screen. Ooh, wow, Anthony got the same result as you showed me a minute ago. But let's look at some math. So let's see how long it takes to do the first one. Bring down 900 objects. All right, that takes 876 milliseconds. But let's push it all in the array and let the array do the hard work of the REST API. It's 10 times faster. All right, 900 objects, 10 times faster, 800 milliseconds. Doesn't sound too great, but think about high latency connections, doing this at scale. This is when that adds up fast, right? When you're shaving milliseconds down. And so that's one of the core things I wanted you to walk away with today is let your REST API do the work for you, right? Because as PowerShell pros, we're so used to just pipeware object, right? And there's better ways of being able to do that and better ways of being able to manage your information at scale. And similarly, we've done things like this. If I want to get an individual object to interact with or filter, well, I can do a where object, and I can do all this super great string manipulation to match the pattern that I want to match. But REST APIs will give you that functionality as well. So I can push that into the API and run that same exact or similar code and get the same exact output. And anybody going to guess how much faster that is? I run those two together. So 1, 2, run those two back to back, 153 milliseconds, 900 milliseconds. And so notice the pattern there. It's generally going to be a lot faster to let the array do that and then transact that all back local to me because the amount of data literally is getting shrunk. JSON super verbose, limit it down, and then ship it is what's going to happen there. So that's kind of the key takeaway when you're working with the REST API is to leverage it, let it do the work for you so that you can get the things that you need done faster and at scale. Because again, this doesn't sound like a lot, 900 milliseconds to 153 milliseconds, but again, do that 1 million times or 10 million times, and that's going to matter. Cool. All right, let's make a SQL Server sad. So what we're doing here is I'm going to start a job in my data or in my lab, and it's going to run a backup with compression, which in this specific system lights up the CPUs because backup compression is generally a pretty hard thing to do. I love performance. I've mentioned that a couple of times. And on our platforms, and most platforms, you get the ability to ask for performance data, okay? And so we have a model that shows the performance characteristics of an object, whether it be a volume or an array, to expose information about it. And we have kind of all the base stuff that you'd expect from an object, but then it gets pretty nerdy pretty fast. Bytes per mirrored write, bytes per op, bytes per read. So pretty discrete metrics describing the performance characteristics, in this case, of a volume, right? And that volume being a block device I'm going to expose to a server. So I'm going to use the same exact technique that we just inspected a second ago, but on a lot more data now. Now we're looking at dozens of potential properties I want to be able to consume and do some work on. So I want to get the performance data for a particular, or top 10 volumes, sort it by reads per second and descending. So basically tell me what's the hottest volume going on right now. And you can see there's two that are fighting for kind of the top billing there, MuttDB01 and AEN SQL 22. MuttDB01 is going to be showcased on Thursday in the machine learning talk, just so you know. That's why it's been running for multiple days. But I can very quickly ask my system for who's the top reader in terms of I/O. So those two stand out right away. And I can also get the bytes per read, which is something super interesting to DBAs because that's the amount of data or the size of the I/Os that are occurring. So that's a 0.5 meg I/O that's occurring in our system. But we did all that on the array side, but sometimes I still have to do calculations. And unfortunately, on our array or on our REST API, we don't have that ability to be able to do calculations remotely. So in this scenario, I do have to bring all the data down. So I'll use a technique like this, where I'll get a sample, pull it down, and then I'll work with that sample at that point in time. One of the things that we've done on the performance side of the house is I can ask for ranges of data. So I can say, give me all of the performance data for a particular volume over the last year, 6 months, 3 months, and then start doing that work on that data locally. So again, knowing where that data lives is kind of the critical thing here. If I want to do the math on it, I got to bring it local. And then rather than doing it over a pipe, because that'll take time, being able to do that iteratively. So pretty cool there. Yeah, and that's, I got ahead of myself. I want to go back and look at some previous historic data. So this case here, let's go down a little bit further. I'm going to do some date math. Time zones are not my jam. If you ever look that up on Twitter, I have lots of commentary from my friends tormenting me about how bad I am about missing meetings. I legitimately went an hour over on a conference session. I thought it was a 1 hour presentation. I spoke for 2 hours, and then I asked my co-presenter, I'm like, how'd it go? He's like, you're exactly 1 hour over. I was like, ooh, wow. Time zones are not my friend. He's like, why didn't you stop me? He's like, it was good stuff. And I'm like, oh, great. So anyway, so basically what I'm asking here is I'm going to ask the array, you know what? Give me 3 days, give me 24 hours of data from 3 days ago. That's what I'm asking for. And so when I run this code here, I do all the math, which I'm really not good at. And then I can ask the array, you know what? Give me all of the data for reads per second descending, top 10, but for the date range of 3 days ago up until 2 days ago, and give me that sample. And so if I go and look down here, I'm back in time. Today's the 9th, I think. Yeah, so I'm 3 days ago on the 6th. And so in this case, now I can start to do some analytics on data over time on our platform. And this is what I'd like to see in a lot of API architectures, is being able to let me decide on how to manipulate things from a data standpoint on the array or on the REST side, and then pull that down to operate on it. And then kind of bringing it all together from a funness standpoint, I have get PFA2 volume performance again, giving me the top 10 across the last 3 days, but filtering, sorting, and doing all that science to find out who the hottest volume was 3 days ago. And getting all that in a very efficient way where it's all happening on the array side. So, probably any questions or comments, team? Good? Yeah? Quimby? Good? Yeah, awesome. Now, shifting gears, we get involved in a lot of performance escalations internally, and a lot of customers don't have monitoring systems, and I want to be able to say, you know what, where does it hurt, right? And so we looked at volume so far. We're going to shift the gears over to host level metrics now. So from a host level metric standpoint, we have the ability to do the same thing, but the object model is slightly different in the sense that it has what's called a resource ID, which we're going to dig into in a second here. And so again, I can take the same exact pattern and apply that to the different objects in our system, because the object model supporting the performance data is the same. And so we have our host level performance, and I can say, you know what, this was the hottest volume or the hottest host level 3 days ago. Cool. And then shift that over towards writes per second just to get another peek at a different performance dimension. And there we go there. So reads and writes is something that we're often troubleshooting. So the idea here is we developed a performance model that we can use over different object types, whether it be a host group. We have a concept of pods or directories. And so we're exposing that information to you so that you can do the same exact pattern over and over again, regardless of what that particular object looks like. And that's what we saw there. Cool. Now I'm going to shift gears towards tags. Anyone using tags in Azure or in any other on-prem systems to manage information? Okay. VMware is a big fan too. Okay, so the first thing I'm going to do is I'm going to get a couple big buckets of volumes. I'm going to ask our array for all of the volumes associated with this SQL server that's got this name, AEN SQL 22A and AEN SQL 22B. And so each of those variables now, I just have two big chunks of volumes that are all attached to that VM that I have running in my lab. And what a tag is the ability to add additional metadata information to an object. And then I want to be able to do things based on the tags. And so in our platform, we have a tag namespace, it's kind of like a folder. And then I have a tag key and a value. And so a key is going to give me some unique metadata property to identify a collection of stuff. And then within that collection of stuff, to discretely pick one, right? That's going to be the value. And so let's create those properties. So I have a key and a value and a namespace. And then across all of the data that I just collected, I'm going to tag all of those volumes. And so that's what's happening in this big line of code here is set PFA2 volume tag batch in the array, in the namespace, The difference here is A and B, and then a value. So I basically put all those volumes into 2 big buckets and added tags to them. The important part about this now is I can interact with those tags programmatically. And so I can ask our REST API to give me all the objects that match that tag, right? That's key is equal to SQL instance. So I have 900 volumes on this particular array, but now I have 2 buckets of about 8 volumes that I want to work with. And so then I can start to do things with those particular tags. So I can ask all of the volumes for the resource identifiers, which is a GUID that represents that actual thing, like a key in a database or an individual unique identifier for that object, so I don't have to address them discretely by the user-friendly name. And in our API, we have the ability to pass in the list of IDs. And so I can say get PFA2 volume space for all of these IDs, and then sort it by, in this case, data reduction, which is a space parameter in our platform on how compressible and deduplicatable a volume is. And so now I can start to perform operations on a subset of information. And so this is, I think, extraordinarily powerful from a business standpoint, because how often do we have to go back to a business unit and say, your system's consuming that much space, or your system grew this much space over time. And so leveraging tags in a platform gives you the ability to add that additional information and then be able to perform those operations on that set of data. And so that's where we're seeing customers use that. And then similarly, outside of space accounting, all the stuff that we did above with performance data, I can feed in that listing of resource identifiers again and start to get the performance data for a subset of systems. And so if we look at that output, we can see the performance data just for the volumes associated with those SQL servers and classified over to 2 different instances. And if I go back to the top here, we can see that it was just a REST API call that passed in, where is it? Going blind here. There's the get call against the ID, but then the resource identifiers get passed in as a collection. So a bunch of work happening there under the hood inside of that. And then when we're done, I'd like to clean up my mess. This is just from a lab standpoint because I want to be nice to my coworkers. I want to remove those tags from those volumes. Cool. So I love being able to use that to classify workloads. Tomorrow or Thursday, I'm going to do a bunch of different things with that type of pattern around machine learning. Very cool. Yes. Yeah, so I obviously have like, oh yeah, man, it's like you've done this before. So the question is, can I protect the tags with, I guess, permissions, I guess you could say, right? Today on our platform, no. In the near future, yes. It generally speaking, like if you're looking at like Azure or VMware, that's going to be something, an object that will have a security parameter around it. So that's going to be system specific, right? That's a good question. All right, where are we at here? All right, so snapshots is another thing that a bunch of our customers use. And what I'm going to show you now is how to take some of the same concepts that we've been working with and applying it to just a different problem domain. And so what we're going to do first is I'm going to take a snapshot of a protection group. Is anyone surprised that all the demos are actually working, right? I'm like, I am blown away. All right. Yeah, right. Knock on painted black metal stuff. All right. So I just took a snapshot. On our platform, a snapshot is a point in time representation of the data. It's like bang. And then the data can move forward in time, but that snapshot itself is immutable. And we have a common ask of customers is like, hey, how do I get rid of like all the snapshots older than X? And so what we've exposed in our object model is things like create it. Like, so I can do some math and say, you know what, it was created back then, and I can go and I can pull that all out. We also have the ability to add a suffix, which I think is probably the most powerful feature of our platform when it comes to managing data. That's a pretty broad statement, right? because I can do something like this. I can take a snapshot of a protection group, and I can inject information about that snapshot. So say this was a data warehouse, and I wanted to take a checkpoint along a data warehouse load. I can inject information about what's occurring from a business standpoint or an application standpoint in our system. So now I have a protection group snapshot that I know I can go and say, you know what, I want the data warehouse checkpoint number 1 as a restore point in my platform. And so that's what we're doing here is, well, I'm using get PFA protection group snapshot. I'm piping that over where object. Is that going to be fast? No, because there's probably 10,000 snapshots in this platform. And so we're going to use the filtering mechanism again to minimize the amount of data that's exchanged between the two systems there. So just like before, bad at time zones, so I'm gonna let the computer do the math for me, because this would be what's called a resume generating event if I mess this up, right? I'm not gonna delete the snapshot, but I'm gonna show you is how to get a set of snapshots that are older than a particular date. And on our API, we've actually given you the ability to put in equality operators and range operators. So I'm injecting a filter that says for all the things that are older than the date that we just calculated, sort them, and then do something with them. In this case, I'm just going to write it to screen because, again, I don't want anyone to lose their jobs tomorrow. And so now I have all the snapshots that are older than 30 days. If I scroll back, you can see I'm really not great at cleaning up my messes, right? Because that's a bunch of snapshots that have been laying around for a long time. Cool. And so with that, we go ahead and I'm going to jump ahead to this one here. Yeah, jump ahead to this one, take another snapshot again. And so what I've done here is I've got a listing of all the snapshots, and then now I'm pulling out the resource identifiers because I've been able to pass the resource identifiers into a remove snapshot. So what's going on here is the ability to say, you know what, FlashArray, give me all of the objects that are older than 30 days, and that's how you remove them, but just don't do that. That's why it's commented out. And then I'm gonna go ahead and remove that individual one that we just created, because I need to be able to do that again in the future. And finally, on our platform specifically, when you do remove a snapshot, it puts it into what's called an eradication bucket, like a recycle bin, but I really, really want to get rid of it, and so now I am going to get rid of that. So, any questions or comments around that, team?
What if?
What if? What if? That's a sore spot, man. So Quimby, is Robert Quimby in the back. Raise your hand, raise your hand. He's the PM for this product, actually. So yeah, the what if parameter, obviously being able to do that, but that snapshot's already gone. But so what if is not supported without eradication? So I have to move this down here, actually. That's right. Whoops, down there. But that's going to fail because I already removed it. Interesting comment there. So I talked a bunch about performance data. Was it last year here? Yeah, last year here. I spent a bunch of time working in the OpenMetric space with Grafana and all the telemetry around that. And so last year, I did a presentation here on how to deploy a monitoring platform in a single line of code. And what I deployed is something that looks like this. This is a sneak preview for tomorrow or Thursday. These metrics come out of the same interface that I just described. So our REST API, that performance object model, all of that stuff gets emitted, and we're pulling it into Prometheus and then graphing it via Grafana. And so the idea behind this particular demonstration is the same exact API does all the stuff that we're doing for PowerShell, but also gives us sophisticated information like this, where I can go and I can ask for performance data and graph that from a SQL Server instance. What we're looking at here, I'm going to look at on Thursday, is I'm actually doing predictive analytics on what I think the workload patterns will be. And so we'll get into all that on Thursday. But again, the same interface exposes that exact data. And then in the code downloads here, you'll be able to reproduce this in your environment pretty quickly with Docker Compose. Cool. Awesome. So let's jump back over to here. So all the code from today is going to be available on the conference's GitHub repo and also my GitHub repo. A freshly newly minted link for our FlashArray API reference is the second bullet point there. And I recently blogged a bunch about all the demos that I have here. So if you want to kind of get a walkthrough of all of that, that's going to be available there too. And I'm ending a little bit early, which is never a problem I've had before. Doesn't everybody say that? But I'll hang out for questions or comments as long as y'all want. So thank you so much. What's up, brother? Invoke REST method. So the question is, how much of that is available with invoke REST method? I was like literally going to write that demo this morning, and I backed off because I didn't want to have to deal with all the authentication stuff. That's going to be the hard part. So we're handling. So our platform uses what's called a bearer token to authenticate against the REST API, which is basically a secure exchange of a key, right, for me to get access to a thing and authenticate against the array. That's why I pumped the brakes on that, because I didn't want to go down the rabbit hole of dealing with authentication today, because we're dealing with that in our invoke PFA2 REST request method, and then the regular commandlets as well. And so, yeah, I don't know, maybe between now and Thursday, I'll write that code. Although one of the things I did do this morning, and was probably the main reason why I had to update, what do you call it? VS Code, is I installed Copilot on my work laptop. And so let's do a quick demo. Right? What's that? Is it web request, right? Is it REST method, right? Yeah, it's not. Yeah. So yeah, I don't know why it's not working, but I'll try that out and I'll get it to you, because I think it'd be fun to experiment with that. Right? It puts some code on the screen. That's amazing. I'm not doing a Docker session this year, right? Hold on, I just replugged it back in. Let's see if it thinks about it. Come on, you can do it. You can do it. There we go. So yeah, so I asked it to do that, and it spit out that line of code. But I can't. Will it handle the credential properly? I had not messed with that. Let's see. Certificate. It's going to be now it's a certificate issue. So is there an ignore certificate? Skip. There you go. Stupid Copilot. So yeah, so literally I just asked it. It popped that out. I should have said with skip certificate, and it gave you what you needed, man. Isn't that crazy? So cool. Yeah, that's actually why I installed Copilot this morning, because I wanted to do a quick demo of that. So there you go. Cool. All right, thanks, team. So that's the age. So the question is this, and this is a pretty important question: is as the REST API moves forward, right? Who's responsible for building out the PowerShell commandlet as the REST API goes forward? It's actually an organizational challenge. If you see, like in Microsoft, PowerShell moves forward, but modules might not move forward, and then Azure CLI might move forward because the REST API moved forward there, and then the AZ module has to catch up. And so that's going to become part of kind of the organizational strategy on how you handle change, right? Back to your original question, or the first question is, does it pass it up into the API for the sorting? Let me go back to the way to the top here and show you exactly what that looks like. So if I add verbose here, and in the query string, you'll see the yeah. So there you go. So against that, you can see it's hitting the REST API, then the URI, and then it's passing in the limit there, and then it's reducing the set of information that comes back, right?
Because if you just try to do that in the PowerShell module, it's going to be as slow as if you try to do it locally, right?
Exactly. Yeah. So cool. Good. All right. Thanks, everybody.